Hello again, everyone. In this video, I'm going to talk about Universal Resource Identifiers, or URIs. When I started working in the web, the term we heard the most was a URL, a Universal Resource Locator. I've also heard the term URN, Universal Resource Name. What's the difference between a URI, a URL, and a URN? And more importantly, what is a URI? What information does it tell us? How are they structured? Let's dive in and find out. So if you look at this slide from danielmeisler.com, you'll see a relationship between a URI, a URL, and a URN in this Venn diagram. I think the important takeaway here is that URNs and URLs are a subset of URIs, and that a URI is that universal identifier that can tell us the address and the name of an object. URIs represent resources located on the internet, and that includes resources on the web. The definition of them really does fall from the three words in the name. They're uniform, which means different types of resources, including new ones, can be identified using the same syntax that we're already familiar with from other URIs. A resource is a really general concept. It can include internet resources, physical entities like people or buildings or locations, or even abstract concepts. An identifier is enough information to distinguish one resource from all other things within the scope of that identification. Resources are unlimited. The specification does not place any limits on the nature of a resource, reasons why an application might need a resource. It doesn't limit the types of systems that would use resources, persistence over time, or even particular types of resources. And URIs have a global scope. Now, what that means is they're interpreted consistently. It doesn't really matter the context that they're in. Now, you interpret a URL a certain way, but it doesn't necessarily mean that it's going to actually act or work the same depending on that end user context. Here's an example, http://localhost. Localhost is the generally accepted term for the computer you are making a request from. It is its own address. It usually refers to a special loopback interface that doesn't even require a network card. Its IPv4 address is 127.0.0.1, and its IPv6 address is ::1. So if you were sitting at a machine and you typed go to http://localhost, that's going to give you the web server, if any, running on the current computer. If the person sitting next to you at another computer also goes to that same address, http://localhost, they too would go to the web server, if any, running on their local computer. The scope is the same, the interpretation is the same, but because the context is different in this case, there's a very different outcome, or potentially a very different outcome, because the interpretation is going to be different than the actual result. An exception is allowed for when the context of whatever the URI is pointing to is defining something very, very specific. For example, you can use file : / on all Windows, Linux, Mac OS machines to reference a file on your local computer. And since that is a very specific reference to a local file location, it's okay for the scope of that particular URI to not be considered global, but to be considered specific for where it's going to be used. The components of a URI syntax gets a little tricky as far as how they're all named, but as long as you understand what they do, it's really not a big deal. So the first thing that happens, the first part here before that first colon, this is called the scheme. Again, a scheme could be like HTTP, HTTPS, FTP. We'll look at a couple examples in a few minutes, but we really want to know what is the scheme here. It's interesting to note that Drupal, the PHP-based content management framework, uses public : / and private : / and I believe even temp or temporary : / to reference the directories where it stores its private, public, and temporary files. And so it's a good example of how this can be brought out to mean something other than the common internet services we know. After the colon, the hierarchy part comes. The double slash means that this is an authority. It's like start here. This is the true one and only very top of the address. If it only has one slash, or can sometimes even have no slashes, the path might have a root, might be empty. That really is hard to describe in general terms here, but it does make sense from different contexts. So we have the hierarchy part that is basically where is this resource located. Then optionally at the end we can have a query, and we'll talk about these a little bit more in a bit, or an anchor tag and a fragment, and that usually tells us where within that resource you want to start. A good example would be a web page where it uses an anchor tag that corresponds to a heading somewhere down the page, and the browser would actually scroll right down to that heading that you're looking for, so you can start reading there. So the scheme and the path, the hierarchy part, they're required. The path can be empty, but it's required to have things there. Now let's look at some specific examples to see if we can figure out what this all means. So again, I've got a reminder here at the top that we have the scheme, colon, the hierarchy, a possible query, and a possible fragment. So the first URI we see here is an FTP resource. And so the scheme is FTP. The server part, this is called the host part, is the name of the host that this resource lives on. And then within that host, it lives at RFC 1808.txt. The next one down looks a lot more familiar to most of us from working with the web. It's a basic HTTP is the scheme. So it's a basic web address that we would see. And again, we have the scheme, the separator, the hierarchical part, or the path, which is this host, and then the path on there. And that's that URI. The next one looks a little different. This looks a little funny if you haven't worked with IPv6 before, because we have an LDAP reference. And again, we say, so the scheme is LDAP. We'll be looking for an LDAP server, and whatever's interpreting this should be able to know where and how to find LDAP. That's not really our problem at this point. And then this next part here within square brackets, that's an IPv6 internet address. So that is the host part. Then /C equals GB. And then the rest of these questions become query sections to help query an LDAP resource. Some of you may not be familiar with the mail to reference, and some of you are, but this is a way that you can put an email address in a link in a web document. So the scheme is mail to, and then the email address is the path. So in this case, this isn't a physical resource like on a server. Example.com might not even be the actual server that you go to, that the mail goes to, because it's going to go to the mail exchange for that domain. But again, we have scheme, we have the separator, and then we have some kind of hierarchical reference to tell us where this resource is located and what it is. Going on down, we have a news reference, and it references a news group. That would be a Usenet link. Telephone numbers, this is a way that we can embed telephone numbers in links or refer to telephone numbers. Telnet, this Telnet client is actually going, I look at this and I say it's going to a host of 192.0.2.16, and then I know from the way that Telnet references are built that :80, it's actually going to probably connect to a web server. So someone would use this if they were using Telnet to try and diagnose what's going on with a web server connection. And finally, this other universal resource name of some sort looks like this is part of the DocBook specification. I don't know a lot of details about this, so I don't know. I don't really know how to interpret this right off the top of my head, but I do know what this is, and I do know that it's some kind of DocBook reference, and I know that I could look it up, and it's actually, I could guess from this, that's a document type definition, that the document is in XML format, and then this would be a version number. So this is a URN that's telling me that to get the document type I need for this XML document, go read this specification. So especially in HTTP scheme or FTP scheme, things like that, it often becomes necessary to specify the port. In fact, we could always specify the port, but because we have defaults, we don't have to. The default port for HTTP protocol is port 80. The default for HTTPS, which is the secure version of HTTP, is port 443. Web servers can be run on alternate ports, and that can be specified in the URI. For example, if I have a web server running on port 8000 or a secure web server running on port 8443, the URIs for those would look like the ones shown here. And finally, the path in a web URI is the location of the resource within the server. I kind of mentioned this already. We have the scheme, HTTPS, the separator, / www.hfcc.edu would be the host portion, and then the path portion of this URI would be steps/apply in this case. I mentioned before that you can append queries to the end of a URI. This is optional, of course, but it sends additional information to the server about the request. It's separated from the path with a question mark, and it may consist of alphanumeric characters and the characters shown here. An example would be question mark page equals 13. Now you notice that the equal sign is not part of the characters that I've listed here. That's because the equal sign is one of the special characters for URIs that's used to help build queries. Some URIs are case sensitive, some are not. The host portion of a URI is never case sensitive. DNS doesn't care about case. DNS does not work or look up by case, so the host can always be whatever case you want. The path portion of a URI might be case sensitive, but it depends on the web server. Linux and web servers running on it are case sensitive. Linux really does care about case. Windows, on the other hand, is not case sensitive. This is really important to remember if your developers are developing on a Windows platform and creating files and linking to them without paying attention to the case of their files. And then they upload it to your web server, which is running Linux, and then they come calling you saying, why don't my pages work? In that case, it might be up to you to explain to those developers that they need to pay attention to case when they're building links between their pages, because on a Linux web server, it really, really matters. And that pretty much sums up everything you need to know about URIs, at least for now.